In this video, we're going to learn how to solve recurrence relations. So what this means is we might be given a sequence defined by this linear recurrence relation, so un plus 1 equals aun plus b. So you can see here normally we would have constants where a is and where b is. So currently a and b are unknown, but other information we might be aware of are several terms of the sequence. So we might be told, for instance, what u0 is, u1, u2. Any consecutive terms would help us here, and that would allow us to find the values of a and b. And we can then solve for a and b using simultaneous equations, which you learned in National 5. So let's just go on with an example, folks. So the first one, a sequence is defined by un plus 1 is equal to aun plus b, with u1 equal to 4, u2 equal to 3.6, and u3 equal to 2.04. And we've defined the values of a and b. So, firstly, you should remember that this term here is the next term in the sequence, with un being the previous term. So if we say that this is u1, then this must be u0. Okay, so like we've done here, so u1 is equal to a times u0 plus b. Now if we do the same for u2, u2 would be equal to a times u1 plus b. And similarly for u3, u3 is equal to a times u2 plus b. So at the moment I'm only using this bit of information in the question, but I do need to bring these in. So I do know u1, I know u2, and I know u3, and this first equation here you can see involves u0, which obviously isn't a piece of information I have, so I can get rid of that. Now, u2 I know is equal to 3.6, so I can substitute that in, and that's equal to a times u1, which is 4, plus b. If I look at this other equation here, that will be 2.04, which is u3, is equal to a multiplied by u2, which is 3.6, plus b. Just tidy those up. So that's 3.6 is equal to 4a plus b, and 2.04 is equal to 3.6a plus b. And I should have said as well, I started off, I showed you 3 equations, but remember we've only got 2 unknowns, a and b, so I actually only need 2 equations to be able to solve for those 2 unknowns. So it's good that I've got these 2, which involve the information that I've been given. So I'll write these out like my simultaneous equations would have been written last year in National 5. So 4a plus b is equal to 3.6, and 3.6a plus b is equal to 2.04. Now I'm looking to eliminate one of my variables, either a or b, and I can see here that b is the easiest to eliminate. If I subtract the second equation from the first, then I will get 0b, so that's really useful here. So that will give me 0.4a plus 0b, so just 0, is equal to 1.56, and dividing throughout by 0.4 gives me that a is equal to 3.9. So that's half my answer. I have to find the values of a and b, so I've got half of that, I've got a. And I then go back to my original equations, and I'll just use the first one here, 4a plus b is equal to 3.6, and instead of a, I've got 3.9. So I'm substituting 3.9 in instead of a. So 4 multiplied by 3.9 plus b is equal to 3.6. That is 15.6 plus b is equal to 3.6. And if I subtract my 15.6 from both sides of the equation, I'm left with b being equal to negative 12, which is the final part of my answer. So that recurrence relation would have looked like this: un plus 1 is equal to 3.9 un minus 12. So at this point I would pause the video before the screen goes blank and copy this note into your notes jotter.